Did you know that your home Wi-Fi, your company's office, and data centers all follow a handful of proven architectural patterns? These network architectures have survived the test of time and they just work. In this video, we'll cover architectures every network engineer needs to know. By the end of this video, you will be able to understand legacy topologies, 3-tier network architecture, and 2-tier network architecture. But that's not all. We'll also cover modern network architectures like spine leaf, cloud network architectures, and how they are all connected with WAN architecture. So let's dive in. Let's start with legacy topologies. First is the bus topology. It is the one shared cable. Every device taps into it. Cheap, but one break takes down the whole segment. To solve it, star topology was invented, wherein every device connects to a central switch. If one cable fails, only that device drops. This is what a small office or home office looks like today. However, this makes the central switch a single point of failure, which is exactly what the bigger designs solve for. Modern architectures use the 3-tier hierarchical design, which has 3 layers. First is the access layer, where end devices plug in, like laptops, phones, printers, cameras, and servers. It handles port security, VLANs, and power over Ethernet. The next one is the distribution layer, the policy layer. Routing between VLANs, ACLs, and QoS happens here. This is usually where layer 2 ends and layer 3 begins. It aggregates traffic from multiple access layer switches. The third layer is the core layer. It is pure speed. It moves traffic between distribution blocks as fast as possible. Redundancy is placed in every layer. Dual uplinks, dual core switches, so no single failure takes the network down. Spanning tree or better, virtual port channels keep those redundant links from looping. It is used for medium to large enterprise campuses like headquarters, university, and hospitals where there are hundreds to thousands of endpoints across multiple buildings. If the site is small, collapsed core is used. It merges distribution and core into one pair of switches, handling both routing and fast forwarding. It is used for smaller campuses and branch offices where traffic volume doesn't justify a dedicated distribution tier. It's simpler and cheaper, but that core pair is doing double duty, so redundancy matters even more. However, in data centers, traffic patterns are mostly east-west, which are server to server, like microservices or storage replication traffic. To optimize the traffic path, spine leaf architecture is used. Spine leaf architecture, also known as clos architecture, is where every leaf switch connects to every spine switch. So any 2 servers are always 2 hops apart. No distribution layer, no spine to spine or leaf to leaf links. It can easily scale horizontally. If you need capacity, add a spine. If you need ports, just add a leaf. It is used in data centers, cloud environments, and anywhere with heavy server-to-server traffic. It is the standard inside AWS, Google, and most modern private data centers. Spine leaf is how most cloud providers build their physical data centers. As a customer, you're working a layer up with cloud dashboards to manage the cloud network. In AWS, Azure, or GCP, you define a virtual network, a VPC, and carve it into subnets, public and private. Public with a route to an internet gateway, and private with no direct internet route. Route tables and security groups do the job like VLANs and ACLs do on-prem. For redundancy, resources spread across availability zones. And to connect back to on-prem, you're using a site-to-site VPN or a dedicated link like Direct Connect, effectively making the VPC just another site on your WAN. It is used in any cloud workload, and increasingly, almost every enterprise network in some hybrid form. To connect different sites and cloud networks all together, WAN architectures are used. Hub and spoke puts one central site in the middle, a headquarters or a data center, with every branch connecting back to it. Simple, but the hub's a bottleneck and a single point of failure. For redundancy, you can use full mesh, which connects every site directly to one another. It provides shortest paths with no single point of failure. But the links pile up fast. 6 sites means 15 links. To balance the number of links, most real WANs land on partial mesh. Direct links between the busiest sites, hub and spoke for the rest. Modern SD-WAN makes that a lot easier to manage dynamically. To recap, bus and star are the foundation. 3-tier or collapsed core are used for campuses. Spine leaf and cloud VPCs for data centers. Hub and spoke or partial mesh for tying sites together. None of these are better in isolation. It depends on your traffic patterns, budget, and redundancy needs. Most real networks today are hybrids of several of these. That's it for this video. Thanks for watching, and I'll see you in the next one.